Okay. Good morning, everybody. Hey, we're going to continue with just problem after problem using our proportional reasoning skills and strategies to answer all kinds of word problems or real life, real world context problems and that kind of stuff. So even though it says write the assumptions that must be stated to make the proportion a problem, on Friday's test this week, and there's a test this Friday, make and label a factor puzzle for the problem, box the unknown. You will not have to, write the assumption. What that is addressing is the fact that there is a constant rate occurring in each of these problems, and that's the assumption that there is a pattern to our ratios and that all of these would be a ratio table, or we could build a ratio table if we needed to. But we don't need to. Proportional strategies and factor puzzles allow us to find answers a lot quicker than finding a basic ratio and then scaling up or scaling down by a multiplier. So the assumption is that these two bands that are marching, that whenever band A has 15 people on the field, band B has 6. So that's our assumption that this is a constant rate, 15 to 6. So the label part of the directions, I'm going to put band A here and band B. I'm going to label. In other words, anything that shows up under this column is going to be related, the amounts, to band A, and anything in this column is going to be related to band B. So let's fill in from this first sentence. When band A has 15 people, band B has 6. That's the assumption, that this is the pattern to their marching in rows. What if band B has 14 people on the field? Now, again, if this is a constant rate or there's a pattern to how many people are marching in their rows, then we can use a factor puzzle now to figure this out. Some of us are still, we're setting up the factor puzzles okay, but at this point you need to remember, you can still put all 4 of them around, but we can start getting rid of that. But because the lines are there, I will put them in. Start with the row, find the greatest common factor of 15 and 6, and I will tell you that that is 3. And then work from the inside out. 15 divided by 3 is 5. I still have some kids who want to start with this column. Don't start with the column, start with the row. And once you find that greatest common factor, then start your dividing from the inside out with that row. 6 divided by 3 is 2. 14 divided by 2 is 7. The missing box is 35. So when band B has 14 people instead of 6, to keep the pattern, band A will have 35. An aquarium has 32 angelfish for every 12 snails. So this is the pattern they're telling us. This is the pattern. Every time there are 32 angelfish, there are 12 snails. So if we had a bunch of aquariums lined up, this would be the pattern that they would add fish and snails to that aquarium. How many snails will there be when there are 72 angelfish? So my headings are angelfish. That's the label. 2 snails. And then I fill in the first row with the given ratio from the word problem. So you have to go back and read it again. Go ahead and do so. 32 to 12 is the given ratio. And then the second row will be where the question is. How many snails? Ooh, there's the question. Listening to your ELA teachers, this indicates a question is coming up, this word how. How many snails? So I go to my column. I'm looking for this box right here. Will there be when there are 72 angelfish? 72. And again, remember your calculators are allowed. Start here with this given row. The first thing I'm going to do is the greatest common factor of 32 and 12. And I will tell you that that is 4. Okay, greatest common factor is 4. Now I work from the inside out. 12 divided by 4 is 3. 32 divided by 4 is 8. 72 divided by 8 is 9. And then, 8. And then 3 times 9, 27 snails will be the pattern of snails in an angelfish. The problem is right here, you don't have to do anything, worry about this. If this shows up in your Think Central homework assignment, there will be drop-down menus that you can select and fill in the blank. What they're looking for is, the assumption is that there is a pattern to adding angelfish and snails to aquariums, and this is the original pattern. So the problem solution is 27 snails. Anne made 35 posters while Jim made 14 posters. How many posters had Jim made when Anne made 15? So we have Anne is making posters at a rate of 35 posters while Jim is making 14 posters at the same time. So she makes more than Jim in the given amount of time. How many posters had Jim? So we're looking for how many does Jim have when we know Anne has made only 15. Okay, greatest common factor of 35 and 14, 7. Inside out, 2, 5. My bottom row got cut off here. 15 divided by 5 is 3. 2 times 3 is 6. The solution to the problem is Jim will have made only 6 posters when Anne has made 15. That's how proportions work. There's a pattern, there's a rate that's occurring constantly. Okay, solving factor puzzles like this, there's not a word problem, these are just ratios. Please take note of the ratio notation. A is to B is the same rate as 15 to 40. So how can you set this up? Look at your ratios as rows. A is to 32. The order is important. You can't flip-flop these. And then you transition this one is the same as 15 to 40. That's how ratios work. These two are occurring at the same rate. There's a pattern here. They're not nice whole number patterns like we use when we find equivalent fractions. So now we're going to use our factor puzzle strategy. And I'm just going to put these here because I don't need to put them all the way around. And in this case, the row that has 2 given values happens to be on the bottom. And you could have put it on top. It's just that the order of where you put 3 of the 4 numbers to find the 4th missing one does matter. The ratios need to go in the same order. A is to 32 as 15 is to 40. If this were a complete table, these first numbers would be the left side of our table, and these second numbers would be the right side of our table. Greatest common factor of 15 and 40 is 5. Working from the inside out, 40 divided by 5 is 8. 15 divided by 5 is 3. 32 divided by 8 is 4. 4 times 3, A equals 12, a value of 12. Pause the video here if you have an example of the packet or were able to print out the packet PDF from yesterday. Try out these problems and then try them out on your own, and then start the video back up again and check your answers, check your work. Okay, hopefully you followed the directions and paused the screen and tried out these factor puzzles and are recognizing how ratios are written using a colon and 2. This is one ratio equal to a second ratio, which 2 equal ratios are considered a proportion, and when that happens we can use our factor puzzle skills to solve for the missing value in the proportion. So I have I'll let this top row of answers show for you to check your work. And then, or you can pause and check your answers. And I'll just finish this last one out, excuse me, live. First ratio is 63 to 28. I'm going to put that in the top row. And there's some new notation here that I want to highlight. Because we're talking about ratios, this is an indication, these 4 dots that make a square indicates that you have a proportion, which instead of equals, this indicates that you have a proportion, a proportional relationship, which is a fancy way of saying these would be 2 rates in a same table, which is also an indicator that you can use our factor skills, our factor puzzle skills to solve this. It's just a different look. It's a different notation indicating some other things are automatically true. So, and then the second ratio is H to 36. And if you notice, I've taken away the other, corner of factors. We're going to start trying to eliminate that. I'm trying to make this more look like a table, that this top number up here would be your basic ratios or your ratio simplified. And that would be the ratio for the entire table. And that you could find that basic ratio you could multiply to find other values if you want to. See here, 63 and 28. I believe the greatest common factor is 7. 63 divided by 7 is 9. 28 divided by 7 is 4. 36 divided by 4 is 9. And then to find the missing value of H, we would multiply 9 times 9, which the solution to this factor puzzle, or to the solution to the missing value in this proportion, is 81. Okay, so proportions with basic ratios, all of this is you can still solve this the same way. Show a simple solution on your math board. That's not going to be required. You can just continue to use your writing tab on. I've seen some of you use the writing tab on your Chromebook. I don't know what it's called, Sketchpad or something. Some of you use scratch paper, pencil, scratch paper. Some of you have printer access at home, so you printed out the workbook pages that match some of these examples to keep on hand as you do your homework. But all of this is just another way of solving. This really doesn't mean anything. It just tells you that one of your 2 ratios will be the basic ratio in the proportion, because if you look at it, the greatest common factor of this ratio right here, 2 to 3, or 2 and 3, is 1. Therefore, that's the basic ratio. This would be, if we were to build a table, this would be our first row. This would be the rate for all the other rates in that table. Okay, and this would also be in row 1. And then row 2 would be the basic ratio times 2, which would be 4 to 6. But that's just, that's what this indicates, is that one of your 2 ratios will be the basic ratio. You don't have to build a table, but it doesn't change the way you can solve this. 2 to 3 is proportionate to 10 to A. And if you want to, on your scratch paper, you can build your factor puzzle around the 2 ratios. This is going to be 1. And then working from the inside out, 9 divided by 3 is 3. Oops, that's an A, sorry. 10 divided by 2 is 5, which then the missing value for A to keep these ratios proportionate is 15. Okay, so in this one, they don't give us the basic ratio. And how do I know that the basic ratio isn't given to us? It's because I know that these are both even, and I know that this ratio right here, this second half of this proportion, could be reduced or simplified. All right, I'm running out of time for this recorded message, so I'm going to pause, and I have a couple more examples for you to help you with your Think Central homework coming up.